wonder all the time. Okay. All right. So remember that when we first started graphing so long ago, we got these things from the unit circle, right? Now, tangents are where, again, we picked out where all the ones and zeros are. Okay, so take a look at this chart right now. Let's worry about this in a second, okay? At zero, so right here, the tangent is y divided by x. So it would be 0 divided by 1, which is 0, right? At pi over 4, it's root 2 over 2 divided by itself. So if you take a number, divided it by itself, the answer is 1, right? Okay. Pi over 2 is up here, right? The y divided by x would be 1 divided by 0, which is undefined. Thanks, Angie. Right? That says undefined. Okay? How do you graph an undefined, Miss Fleck? Holy shift. Check out that asymptote on that function. Right. When it's undefined, it's an asymptote, which is great. Those are easy to graph. Okay. Here we go. The question is, where is negative pi over 4 and negative pi over 2? Well, if you remember, there's a couple ways to do it. You could change it to degrees and add 360 to it. But if you remember, negative angles go clockwise or counterclockwise? No, clockwise actually, because this one is going clockwise. Good try, though. Counterclockwise, right? So if this much is positive pi over 4, then going the same distance this way would be negative pi over 4. So just remember that negative pi over 4 is the same thing as 7 pi over 4. It's in the same position, okay? On our graph, though, we do negative pi over 4 because it's part of the interval, okay? So at negative pi over 4, again, we have the number divided by itself, except one's positive. So it's going to be negative root 2 over 2 divided by root 2 over 2. What's that answer? Negative 1. Yeah, it's negative 1. Okay? Now, negative pi over 2 would be the other way from pi over 2. So instead of pi over 2, it would be at, yeah. So this is the same thing as 3 pi over 2. It's going to be negative 1 divided by 0, which is undefined. Okay, here's what your highlighters are for. Ready? I'm going to get rid of this. Here we go. Delete, delete, delete. Okay. All right. Here's how easy it is to graph tangent. You ready? Right? Whenever you see an undefined, those are asymptotes. Okay? Asymptotes is only spelled with one S, by the way. Right? Asymptote is only spelled with one S. Just say, unless at the end. Here we go. So whatever is highlighted is an asymptote. When you highlight an asymptote, you can do like a dashed line. Okay? Or you can use your highlighters to do asymptotes. Basically, it's not part of the graph. The graph does not exist there because at that point, it's undefined. So, here we go. For the x values, we've got negative pi over 2, pi over 4, negative 0, and then pi over 4, and then pi over 2. Okay? And for the y values, our highest number is 1, and our lowest number is negative 1. Okay? All right. For an asymptote, all you have to do is draw a dashed line where the asymptotes are. So we know we have asymptotes at pi over 2 and negative pi over 2. Okay, about to blow your mind. Eddie is not sitting in his chair, but he looks like it. His butt feels like he's touching that chair, but you're not. Because in quantum mechanics, your atoms are actually repelling the atoms of the chair. So you're actually just floating above that chair. You're not actually sitting on it. But I hope not, because that would take into gaseous matters, and then we're not even going to talk about that. So here we go. So what an asymptote is, right? It's like a force. It drags the graph close enough to it, but also repels it, so it will never cross or touch that boundary line. Right? Yeah. So here it is. All right, here we go. Okay. At -4, I'm nuts. Here we go. At -pi/4, we have -1. At 0, it's 0, and then pi/4 is 1. Now, I know that looks like a straight line. I know it looks like a straight line. It is not. It is not. Okay? Here we go. What happens is it comes closer and closer to that asymptote. So you draw kind of half a parabola that way, and then you draw the other half of the parabola going this way. So it comes closer to the asymptotes on both sides, but it will never touch it. Yay, physics. Yeah, that's why I went like this. Right? So if you need to remember how to, do your yoga moves, this is you. Yay! There's your little shoes. Yeah, little shoes, and then here's a little happy face. All right. That's you doing yoga. Right. I know. It looks so good. Okay. All right. Here we go. Which means that, let's go back to the top where we analyze everything. Here we go. The domain and range of the asymptote. Now, this looks terrible. This is higher level math stuff, but you're in a higher level math class. Do you need to know this? All this is saying is that there is an asymptote at every other pi/2. Does that make sense? Yeah, every other, because isn't 0 like 0 pi/2? True? So like every other pi/2, there's an asymptote. That's what that's saying. Every other one, there's an asymptote. Does that make sense? Because 0 is a pi/2 too, isn't it? Yeah, but it exists as 0. So the next one, so there's 1 pi/2, 3/2, 4 pi/2 is going to be the other asymptote if we keep on going. Yay? Okay. And then the range goes from -infinity to +infinity because it's always going up and it's always going down. Joy. That's fascinating. All right, here we go. The x-intercepts for this one is every pi it will cross, right? So 0 is a pi because it's 0 pi. So every pi it's going to cross the x-axis. So the next time it'll cross will be, if we go this way, will be, this is 0 pi, so the next one will be 1 pi, and then it crosses 2 pi and 3 pi and so on. The period, it keeps on going on forever and ever. So like this is just one period. You could draw like the next one like over here, and it could just go like this again, right? So it goes on forever and ever. I could draw another one over here and then draw another one. So it just keeps on repeating itself. Yeah, they'll never touch. They'll never touch, right? Yeah. Okay. The period. Here we go. The period is pi for this. If you take 1 pi/2 minus 1 pi/2, just subtract it to find the distance. What's 1 minus -1? 0. Is it 0? It's 2. 2/2 is 1 pi. So the distance between here to here is pi, and that's how you find the period. That one I'm not going to stress as much as the 2 pi thing, but just know that the distance is just pi instead of 2 pi for tangent, cotangent. Yay? Okay. The big part is the graphing part. So let's do cotangent. I'll show you how easy this is. This is excellent. This is cake, some would say. All right. Notice the change. Notice the change for cotangent. Tangent was from -pi/2 to +pi/2. Cotangent is a shift of tangent, so it's from 0 to pi. Okay? Here's why. At 0, cotangent is x over y. So at 0, it's 1 over 0, which is, yep, undefined. Again. Right? What's cotangent at pi/4? It's 1. X divided by itself is 1. at pi over 2, it'll be 0. Good. If you're not sure, it's 0 over 1, which is 0. At 3 pi over 2, which is, or 3 pi over, wait, pi over 2, 3 pi over 4. Sorry about that. That should be 3 pi over 4. Sorry about that. Yep. And then you got -1. Negative pi over 2 divided by 2 is -1. And then back to pi, which is right here, undefined. So this is undefined 2. So take a look at the pattern. It goes 1, 0, -1, whereas tangent went -1, 0, 1. Because it's going from the bottom to the top, and whereas cosine is going, cotangent is going from top to bottom. So from the pointing up to pointing down. Right? Okay. Let's graph this puppy. Delete. There you go. There you go. Yeah. This is so easy. Here we go. Asymptotes where they're undefined. So all your graphing is this part. Easy. Here we go. 0, pi over 4, pi over 2, 3 pi over 4 to pi. Right? The asymptotes are at 0. So I'm going to draw a dash line at 0 and a dash line at pi. Yeah. Oops. Sorry. Okay. And then I need 1 and -1. All right. So cosine starts at 1. So it's pi over 4 is 1, then 0, then -1. Again, it looks like half a parabola. Right? And again, you could continue making cosine functions, you know, that repeat themselves like over and over and over again. Okay? Okay. So for tangent, there was an asymptote at every other pi over 2. In this case, you have an asymptote at 0 pi, an asymptote at 1 pi. Where's the next asymptote going to be? 2 pi. So for the domain, there is an asymptote at every pi. So n stands for any, right? At any pi, there's going to be an asymptote. Find balloon. Balloon? Balloon? Balloon. Yay? Okay. And then it crosses the x-axis, it looks like, at pi over 2. So at every other pi over 2, you're going to cross the x-axis, and the period again is just pi. For this. Bless you. Okay, so how do we set these two equations? Ready? Oh, yeah? Okay. All right, so depending on whether it's tangent or cotangent, right? For tangent, if you take a look, you have to be between -pi over 2 and +pi over 2 to solve it. And then for cotangent, it's from 0 to pi. So when you set these things up, it's slightly different. Sine and cosine was easy. It was always 0 to 2 pi, right? Now it depends. Here we go. To find the period of either of it, remember the period is pi, and you're just still dividing by b. But it depends on how you set up, if it's tangent or cotangent. If it was tangent, you're going between -pi over 2 to pi over 2. Yay? If it's cotangent, then you're going from 0 to pi. Yeah. Okay, so it depends on which one we're doing. And that's how we set it up to find the intervals. Yay? Luckily, 2 of the intervals are going to be your asymptote, so that's going to be the first and the last, and then you just have to find the 1s and 0s in the middle. Yeah? Yeah, okay. I see you're so excited. Here we go. What? Oh, to go back? Go back? Sorry. Were you supposed to write everything? Oh, yeah. Oh, yeah. Is it good? Okay. It's not good. I wait. We're good? Okay. All right. I think I revised your notes and I went ahead and deleted all this, didn't I? Yeah. Sweet. Good. So you got room to work. Yay. Yeah. Delete. Okay. So here we go. We're doing tangent, right? Since we're doing tangent, then our 2/3x is going to be between, good, over 2 to positive pi over 2. How do we get the x by itself? Yes, multiply everything by 3. So if we multiply everything by 3, it's going to cancel that 3. So you got negative 3 pi over 2, 2x, 3 pi over 2. Then you divide, what did I do? I forgot the pi. God bless you, my child. Here we go. Now, over 4, very good. Take everything and divide by 2, which cancels that out. So it's negative 3 pi over 4x 3 pi over 4, which you are no longer afraid because you can do fractions in your head. It's so easy. I almost had them. Here we go. All right. Negative 3 pi over 4 and 3 pi over 4. Yay? Added, divide by 2. It's 0. Yeah, 0 would have to be the halfway point. Okay? And let's go ahead and put 0 over 4 just to make it happy. Yeah? Negative 3 pi over 4 plus 0 pi over 4 is... Right, but divide by 2, this would have to be negative over 8. Paige, you still awake? Okay, just checking. Because when you divide by 2, you can't divide 3 by 2, right? So you multiply the 2 to the 4. 2 times 4, yeah. Okay? And then this one is... Yeah. I like tangents. They're actually... Tangents easy. Okay, here's the beauty of it. You ready? Okay, highlighter. Yeah. These are asymptotes. Those are undefined. That's it. So when you're doing tan, that's undefined, that's undefined. Tan goes negative 1, 0, 1. It's true? You never got to highlight it? Oh. Yeah? There you go. Yeah. So when you're graphing this at negative 3 pi over 4 and at 3 pi over 4, you just draw asymptotes down those ends. Right? I know, it's awesome. And then here's one. Oh, negative 3 pi over 8, and then 3 pi over 8, and then 0, and negative 1. So we got negative 1, 0, 1, graph, ta-da. I like these ones. Don't you? They're okay. I haven't sold you yet. Yeah. Yeah, bud. At the tan part? Okay, look back at the first page. The pattern for tan goes negative 1, 0, 1. You know how sine was like 0, 1, 0, negative 1? Yeah. Tan has the same pattern. It's just negative 1, 0, 1. Oh, so it's like cosine. Uh-huh. Well, cosine is 1, 0, negative 1. Yeah. They each have their own little special thing. So it's negative 1, 0, 1. Uh-huh. Yep, because it has to start from the bottom and go to the top. Yeah? Yeah. Yeah. Question.
Okay, for the very first part,
Uh-huh.
will it always be negative pi over 2?
Yes. Tangent is always negative pi over 2 to pi over 2, and then cotangent is always 0 to pi. Right? So they each have their own little thing going on. Yeah? Should we try again? Oh, here's a tangent one. It's a tangent one. Okay. Oh, 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 oh. What did I do? I'm sorry. Delete. There it is. Okay. Ready? Okay. Tangent, again, goes from? Yeah. To pi over 2, always. Okay. To get the x by itself, just divide by 2. So this becomes, dude, this is why you guys are in this class. You can do this in your head. That's good. Right? Yes, you can. Yes, you can. You're good. There you go. Yeah? What's between negative pi over 4 and pi over 4? 0 is 0. Okay? Halfway between pi over 4 and 0. Pi over 0! Woo! Here we go. I know, this gets so much easier the more you do it. Yeah. Okay. All right. We know that the pi over 4, the end pieces are asymptotes, so not even to worry about it. Yay. Tan goes -1, 0, 1. But we have to times it by a half. Tan would be negative a half. So negative a half times -1 would be positive 1/2. Negative times negative is positive, right? But 0 is still 0. Negative 1/2 times 1 is going to be negative 1/2. So, again, you're graphing this and this. Okay? Negative pi over 4 to positive pi over 4 are your asymptotes. It's the same graph over and over again, isn't it? Boring. Here's 1. Here's -1. So we're just going to go to the halfway point. So it's just going to squish it a little bit. But this time, it starts at positive 1/2, 0, -1/2. What did the negative do? The tangent switched it. Switched it. So would you say it made it a cotangent? Maybe. Maybe. Too much. Are you serious? It's 3 points this time. 3! 3! You're lost in the sauce? Oh, no. You got your sriracha? No? No? Okay. Alright. There we go. Alright. Let's do a cotangent one. Let's do a cotangent one.
You said this was
You okay? That wasn't, is that the cotangent? That was a tangent. That was a tangent. Yeah. Let's do the cotangent one. Delete. 2 is easy. 3 is, we probably should have just skipped over 2, right? Whichever. Here we go. Cotangent is between, dude. Yes. Yes. Okay. So 2 pi. Oh, 2 pi came back. That's so nice. Okay. 2 pi is cute. This is well rounded. All right. Here we go. Yep. That one? Anyone? Okay. Here we go. Thanks for the pity laugh. All right. Between 0 and 2 pi. Pi. Between 0 and pi. Pi over 2. And this was, I feel like you've done this a few times, right? You kind of already know it. This is good. This is good. Okay. Wait a second. Those are your asymptotes, so don't worry about it. Right? We're going to do cotangent. Cotangent starts at 1, 0, -1. Right? 3 cotangent makes it 3. This and this is what I need to see on your graph. Yay. So 0, pi over 2, pi, 3 pi over 2, 2 pi. The 0 is the asymptote, and so is the pi over 2. 1, 2, 3. 1, 2, 3. No, 2 pi. 0 and 2 pi are the asymptote. I might have misspoken. I apologize. So there, and there. Woo! Woo! It is not unusual to have fun with trigonometry. To have fun with chemistry? Yeah, chem is track. It's true. Oh, ouch. All right. Holy shift! Check out the asymptote on that mother function. We haven't done any shifts yet. Let's do a shift. Let's do a shift. Yes, stick shift. It's an easy one. Relax. Sheesh. You're gonna drink motor oil? That's weird. Here we go. This one's easy. All right, without even graphing it, how does the graph move? -3. Now, does it move up, down, left, or right? Down. It moves down. Left or right is with the x. This one is just up or down. So we know that this thing is going to go down by 3. Now, let's put it in the graph to prove it. Here we go. Tan x, that's easy. It's just x. Tan is from, over 2 to pi over 2. So there's no special magic in this one, right? Oh, that's, okay, this is the TMI. Here we go. Between pi over 2 and pi over 2. 0. And between that, yeah, pi over 4. These are your asymptotes. Highlighter, highlighter. Ta-da! Right. We're doing tan, so -1, 0, down to up, right? It's tan. Okay? Then -3 plus tan. So -3 plus -1, -4, -3, and -2. So these numbers and these numbers. These are so fast. Here we go. 1, 2, 3, 4. -3, -2. Okay. So, whoa. Check it out. Check it out. Here we go. This turning point used to be at 0. It moved down by Trig. Ta-da! I know, right? Thank you. You want to say that, please? I was. God bless you, my child. Here we go. Last one. Turn your neighbor and say, yay. Wait. You lost. Where you lost? Okay. Because it's -3 plus the line before it. So -3 plus -1 is -4. What's that? You got it? Okay. Yeah. Get into this. This. Okay. Last one. Oh. That's strange. Okay. Here we go. I feel like you're ready for a challenge. Yes. Okay. This is easy. Here we go. What? X plus pi over 2. We're doing cotangent. 0 to pi. Yes, sir. Okay. No. Take away pi over 2. Yeah. Because you're adding it to the x, so to undo it, you subtract it from the x. Right? And it would help to know that pi is just 2 pi over 2. So when you subtract, you got common denominators. We get. Here we go. Negative pi over 2 to x. 2 pi over 2 minus 1 pi over 2 is. What? Does this make it a tangent? I don't know. No. Who knows? Here we go. Did I? Huh? Yeah, okay. So negative pi over 2 to pi over 2. In the middle is 0. In the middle of that is, yep, joy. Highlighter. Am I going too fast? I'm sorry, I slowed down. Oh. Depends. Are you trying? Aww. Here we go. You're welcome, my dear. Okay. We're doing cotangent. Finish off with it. All right. 1, 0, negative 1. And then 3 plus cotangent makes it 4, 3, 2. Okay, I'll wait for you, bud. Pi over 2 right here. This pi over 2. 2 pi over 2 minus 1 pi over 2 is 1 pi over 2, right? Okay. Yay? Okay. So we graph. We graph. And I don't know why I didn't give myself enough room. Yeah, sorry. And then pi over 2. Three, 4. Yay. So 4, 3, 2 goes something like, woo! Woo! So pretty. It's so pretty. Yes, sir. What's up? Yeah, I can fix that. All right, loves. Here we go. Let me hit pause for this thing. All right. I will do one makeup session